video, we're going to go through how we would tackle this grade 9 hidden quadratic question. Now, some of you guys might be thinking, how is this a hidden quadratic? What we need to do, we need to figure out how we can make this in terms of quadratic. So first, let's just look at this. So let's look at this 3 to the power of 2x and this 3 to the power of x. These are both an exponential. Now we need to link it to some topics that we know. So we know indices. I want to see, is there a way we can link 3 to the power of 2x with 3 to the power of x? Now let's look at some indice laws. So as you guys remember, we have an indice law which shows a to the power of x all raised to the power of y would be equal to a to the power of xy. If it's equal left to right, it's also equal right to left. So what I'm going to do, that means 3 to the power of 2x is the same as 3 to the power of x all squared. And we can verify this. Let's do that. When we have a power raised to another power, we just multiply them. So we have 3 to the power of x multiplied by 2, which is 2x. So we've shown 3 to the power of x squared equals 3 to the power of 2x. Now we're getting somewhere. So let's look at the original form. So the original form was 3 to the power of 2x minus 10, 3 to the power of x plus 9 equals 0. But we've made that link. 3 to the power of 2x 3 to the power of 2x is just the same as 3 to the power of x squared. So now wherever we see 3 to the power of 2x, I'm going to replace with 3 to the power of x squared. So we have, instead of 3 to the power of 2x, 3 to the power of x squared. Take away 10, 3 to the power of x, plus 9 equals 0. Now hopefully you can see how this looks like it's in the form of a quadratic. Look, we have this squared term. So we have 3 to the x squared. We have this term, which is just 3 to the x, and it's just linear. It's not to the power of 2. It's just the power of 1. And then we have a constant. Now, we can actually just factorize it like this, but that's a bit more tricky. So let's just make it easy on ourselves. So what we're going to do, we're going to make a little substitution. So wherever I see 3 to the power of x, I'm going to say, let y equal 3 to the power of x. Now, wherever we see 3 to the power of x, we're going to write y. So instead of 3 to the power of x squared, it becomes y squared. Instead of minus 10 times 3 to the power of x, it becomes minus 10 times y. Plus 9 equals to 0. Now, you can see we have an easy quadratic that we can just factorize. So when we factorize this, we're going to get y take away 9 and y take away 1 equals to 0. That means y take away 9 equals 0, so y equals 9, and y take away 1 equals 0, so y equals 1. Now we're almost done, but the question wanted us to solve for x. It didn't have any y's. We just put that y to make the question easier for us. So we need to solve for x. Let's remind ourselves. We said y equals 3 to the power of x. But we know what y is now. So we know y is 9. So one of the values for y is 9. So we're going to write 9 equals 3 to the power of x. Now we can just do this by trial and error. 3 to the power of 1 is 3. 3 to the power of 2 is 9. That means one of the values for x is x equals 2. And now we do the same. So we've done it for 9 equals 3 to x. Now we have to do it for 1 equals 3 to x. Now let's remind ourselves of our indice laws. Anything raised to the power of 0 is equal to 1. So if our result is 1 for an exponential, that means the power has to be 0. So that means x equals to 0. And now we're done. The reason this is a grade 9 question, because It's because with grade 9 questions, they're not going to hold your hand. They're going to give you information and see how you can link topics, how you can be resourceful, and it's testing your problem solving ability. So follow for more GCSE maths content where we will focus on tips and tricks. We're going to focus on exam practice, grade 9 questions, worked examples, and just how to think through these problem solving oriented questions.